Hello and welcome to this new video about preparation for algorithmics. So today's video is called add two numbers. This problem is of level medium and it says the following. So we're gonna have a function called add two numbers, L1 and L2, and L1 is a linked list basically structure that contains nodes that have numbers. So for example, L1 is gonna be 2, 4, 3. So every value is a node that has a pointer to the next node, and the last node has a pointer to null, basically. And that's how we know that it's the end of the list. So we have L1 and we have L2. So basically we have to add these two lists and have the output as the following. So 2 plus 5 is a 7. 4 plus 6 is a 10. So we need to put here a 0 and have a rest of 1 here. So 1 plus 3 plus 4 is an 8. And then this is the result that we need to return. So let's take some examples so we can understand the problem a little further, and then we can basically make an algorithm that solves the problem. So here, as you can see, we're gonna have a pointer. We're gonna have two pointers, one L1 and one L2. So L1 is going to point to the first node, and from that we can basically retrieve the value of the first node. And the moment we do that, we can move the pointer to the next node by doing current node or L1 equals L1.next. So we get the next. And we do the same, and we take the value and we can add it to the other one. So this is how it's going to work. So we're going to do the value here plus the value here. 1 plus 8 is a 9. So we're going to let's create first I'm going to create a node that's going to be called result or root. I'm going to call it root of the result. And I'm going to initiate it by anything. I can just initiate it by 0 because I don't really care about the value in this root. All I care about is the result that I'm going to be computing. So 1 plus 8 is going to be a 9. So I'm going to create a node with a value 9. And I'm going to point the root to 9. And then I'm going to move forward with the pointers to the next elements. So 3 plus 9 is a 12. 12. How can we break down 12? So 12, the 2 here is the new value. So I'm going to do a 2 here, and 1, this one is the rest that I'm going to put here. And then I'm going to point this one here, and I'm going to move forward the pointers again. So here the pointer is pointing to 9, and this one is pointing to null. Null is basically meaning that there is no value, and for that I'm going to replace it with the value 0. So again, we're going to do the same. 1 plus 9 plus 0 is going to be a 10. So I'm going to take this one as the new value, the 0 here, and I'm going to point it here, create a new node, and this one is the rest that I'm going to put here. And then I'm going to advance the pointers L1 and L2 if they can be advanced. So this one can, of course, be advanced because there is a next. So I'm going to advance it here, but this one can't get advanced because there is nothing here. And I'm going to do the operation again. So here, the value here is nothing. So I'm going to replace it by 0. And we have already here a 0. So 1 plus 0 plus 0 is a 1. So I'm going to create a new node, and I'm going to point this one here, and this one points to null. So, and we are done because this one points to nothing, and this one points to nothing. So we cannot move any further. And the result is, this is the result that we should return. So it's a root next, root dot next. So we should return this and not the root. So let's try to code this. So I'm going to create, as we said, the variable root is going to be a node that's going to be pointing to the result. I'm going to just put any value inside because I don't care about the value, and I'm just going to return root.next at the end. And then I need to create a variable called current. That I'm going to initiate by roots, and then I'm going to create res that's going to initiate by 0. So current is the current element here. At the beginning is initiated by root, but it's going to be moving forward. This is current, the element that we are going to be adding. And I'm going to do a loop while L1 different from null. So while we have an element in L1 or we have an element in 2, we should keep moving forward. So we're going to retrieve the value from L1. We're going to do val1 if L1 different from null. So if there is a value in L1, we're going to return, we're going to put L1.val, otherwise we're going to return 0. And we're going to do the same for val2. So if L2 different from null, it means there is a value that L2 points to, we're going to return L2.val, otherwise we take a 0. Here what I'm doing is, if the pointer is here, so if L1, this is L1, so L1 is going to be different from null. In that case, I'm going to take a 3. But in this case, L2, for example, is pointing to null. In this case, I cannot take the value. I'm just going to take 0 by default. And then I'm going to compute the sum. So it's val1 plus val2 plus the rest. And so this is the sum that we saw here. And from this, I'm going to take the right side and the left side. So the right side is the rest of the division by 10. And this one is the sum divided by 10. And we take the integer value. So the new value is sum modulo 10, and the rest, so the rest is going to be sum divided by 10, and we take math.floor. And then we're going to do current next equal to a new node with new val, and we need to move current to current.next, and there that must be it. Like what we did here, we basically created the node and we moved the current to the next one. And then we need to check L1. If L1 different from null, we advance it. We do L1, see if L1.next. If L2 different from null, then L2 receives L2.next. So I'm moving here the pointers, these two pointers, this one and this one. And there is only one missing thing, but I prefer that I show you first the results of the tests. Tuck. Am I doing something wrong? Value. No, it looks good. I think there is some kind of loop, a limited loop or something that I'm missing. 2 or L2. Ah, here. Sorry. Yes. So as you can see here, they pass the test, they pass, but in this one, there is this rest that I missed. So it's basically this case. We have the rest here as 1, and we have nothing that we are pointing to. So we should return here a 1 that we need to add at the end. So all I need to do is if we have a rest that is not null, we need to do current dot next of rest. And there you go. So what I did is I checked if we still have, even though we went out of the loop because L1 and L2, they no longer point to any new node, So all I'm doing is, if there is still a rest that I didn't take in consideration, I need to add it to the result by doing this. So I create a node with rest and I attach it to the list. And there you go, all the tests they pass. Let's submit the solution. And it is accepted. So if we consider the complexity of the program, we have, it's an O of n. So because we only do one loop over the 2 arrays, and also the complexity of memory, we can also consider, we only create this list, but this list is also returned as a result. So we can discard it as a complexity. Normally, some people, they would consider this is an O of n, but I don't, because this is returned, and anything that you return as a result, you don't consider that as a memory complexity. So all we did, beside this list that we return, we created the current variables and these variables, which is an O of 1. Yes. So I hope that you learned something from this program today. If you have any comments or any other solution that you want to discuss, please put them in the comments. And if you like the video, please give it a thumbs up and consider subscribing for more videos. I see you in the next one. Bye-bye.